function f of x squared over 2 to the x. We have to find the derivative, and they luckily showed you the derivative is this. So if we use the quotient rule, we have low d high minus high d low, which is 2 to the x ln 2, all over low squared. Okay, and then I have a 2 to the x on the top and the bottom, so I can just simplify it as 2 to the x minus x squared ln 2 over 2 to the x. Just factor out the 2 to the x and then cancel it. So there's part I. Obtain an expression for f double prime, simplifying your answer as far as possible. Okay, so double I. So low d high 2 minus 2 to the x 2x ln 2. ln 2 is just a constant, so that comes along for the ride. So that's low d high minus high 2x minus x squared ln 2 d low 2 to the x ln 2 all over low squared. Okay, same thing. 2 to the x's cancel. So we have, let's see if I can fit this in here. 2 minus 2 to the x, 2x ln 2 minus 2x plus, I'm not going to fit it, plus 2, no, plus x squared. I'm just going to write it down here. 2 minus 2x ln 2 minus 2x, distribute that negative, is plus x squared. I'm not doing this very well. I'm going to distribute this ln 2 as well. So I get 2x ln 2 plus x squared ln 2 squared, and that's it, over 2 to the x. 2 to the x's canceled with the one on the bottom. Show, and I think negative, and that's a positive. I think it's okay. Find the exact value when f prime equals 0. See if I can fit this over here. Okay, that's good. So let's go. Let's take this out. We have this exact same thing twice. So let's go minus 4x ln 2, like that. All right. So find the exact value of x satisfying f prime equals 0. So this is f prime. Set this equal to 0. I can get rid of the bottom. Just multiply by the bottom on both sides. I get 2 to the x minus x squared ln 2 equals 0. Which one is this? This one. Factor out an x. I get 2 minus x ln 2. X equals 0, but x is greater than 0, so that doesn't count. And then set this piece equal to 0. We get 2 minus x ln 2 equals 0. X ln 2 equals 2. X equals 2 over ln 2. Let's change some colors here. Show that this value gives a maximum at f of x. So if I 2 over ln 2, if I pick something ln 2, yeah, I can pick 1. So I can pick 1. I'll pick 1 right here, and if I put 1 in there, I get 2 minus ln 2 over 2, which is positive. And if I pick, I don't know, what should I pick? Let's pick 3. 6 minus 9 times that will be still bigger than 9, which will be negative. Picking 3. So that goes from increasing to decreasing, which means it's a maximum. Okay, so that one's done. Find the x-coordinate of the 2 points of inflection on the graph of f. Okay, so this is a little bit complicated. Let's move this to the next slide. Okay. So the 2 points of inflection, this equals 0. Get rid of the bottom. I'll rearrange this. I get ln 2 squared. This cannot be simplified. That's as easy as it goes. X squared minus 4 ln 2 x plus 2 equals 0. That's nothing more than the quadratic. I'm not factoring that by any means, but it's still just a quadratic. So we can go negative b. So x equals negative b plus or minus b squared minus 4a c all over 2a. And that can be simplified a little bit, but not much. I think that's fine for me if you leave it like that. Well, 4 times 2 is 8. 4 squared is 16. Do things like that. And there you go.